Hello everyone. Can you hear me?
Yes, I can hear you.
Great. I have a couple people also online. So what I want you to do anyway. So thank you for joining STEAM NOOR class. This is gonna be a first class online. So the one I did last time was a workshop, so I really couldn't give much attention to online kids. So I apologize for that. So my complete focus, it will be online now, and I will have like a question sessions. 1 second to just accept. I have another person just join in. Okay, I think we just wait 2 more minutes. So I'm gonna assume that you don't have this software installed. So the software that we're gonna be using most of the time, it's called Tinkercad. So if you don't have it installed already, what I want you to do, and by the way, you can actually, if you pin me, you will have a bigger screen. So just try to go to my image and pin me, okay? So I want you to go to your favorite web browsing application. Mine is Google. So, and just type under search bar here, type Tinkercad, okay? So this software is really a good software. It's gonna help you basically for those that don't have access to actual hardware. So you can build a circuit using this software, and you can have actually simulation with this software. When we're gonna use also this software to do our 3D design, when we try to basically design the chassis of the car. So it's very important to have this software. So under Google search, type Tinkercad, and I want you to click on link that you see first. And since I have already installed it, I got to this page quickly, but let me just log off. I'm gonna log out. Then once you click on that link, you should come here, okay? So, and I'm assuming you have a laptop already and you're ready to go. So I'll just wait so I'm not too fast. So you cannot just come in and sign in. I already did that. So what you need to do is create an account, okay? So click once you get here. Don't hurry and to put your email address. This is really to sign in. So you go to create an account, and then you select your country, and I'm assuming everyone either from United States or locally in Morocco, and put your information, maybe your father or you take I'm assuming that you can actually just put your information here. It's very safe environment, so you don't have to worry about putting your information. And once you put your information here, just so I'm from United States. Let's say I'm just put some any number really here. Let's say I'm this old. I'm actually older. Go next. And then you put your email address here. That's where you put your email, bejjaji@gmail.com, and choose a password, okay? And once you put that, sign agree and create an account. So once you create an account, you'll be signed in. So I'm gonna wait a couple more minutes to do this step. So as I said, I already did that. So, all right, here's Saousane Bejjaji and Adam Bejjaji, admit. You're welcome, Adam. Thank you for joining my class. This is, by the way, what we did, Adam. We just installed, and I'm gonna repeat this for you quickly. We just installed Tinkercad, okay? So this is the application that you need to have to follow us, okay? If you couldn't do it today, don't worry about that, but just follow me, okay? So you go to to Google search bar and type Tinkercad, okay? Once you're there, you click on this link and just follow the instruction. But for now, since I don't want to delay everyone, we just follow us, and you can always go back and install this application, okay? It's a free application. It's really good for simulation. You don't have to have all hardware components to simulate and have fun. So I'm gonna go now, and I'm gonna connect to Tinkercad using my Google account. So while you're here, and I'm assuming that you created your account and you got to this page, okay? So I want you to click under circuits, click on circuit here, and I want you to click on create new circuits. I'm just gonna wait for you for a few minutes. Is everyone following me? Everything is good? Am I going fast?
No, we're doing good.
Good, good, okay. Just let me know if I'm going too fast. You know, I don't want to go too fast, but I don't want to go too slow either, okay? So once you're here, this is the this side to the left. This is where we're gonna build our circuits, okay? And to the right, you have this box here. This is where all components that you're going to be selecting. Very easy, very basic, really self-explanatory tool. You don't have to really, be a scientist to do this. So let's click on here and select all. You see that? So you will have all components available to you. Okay. And I'm going to come back here. Okay. So now, again, this software is going to help us really understand and simulate circuits. And when I say circuit, is really to build some kind of electronic project. So our first project, as simple as it is, it's really important to understand these steps to be able to use Arduino. And the main goal of this class is to build this smart car that uses Arduino, okay? And that smart car is a bunch of hardware that uses actually electronics, and you have to understand the basics, so that's what we're doing today. So what we need, we're gonna choose all the components that we need. I think someone just joined. Let me just accept that person. Najat Crime. Yeah, welcome, Najat. We just installed. I'm gonna register this class. I'm actually recording this class. So we just installed the Tinkercad. This is the software that we are using to build our first project. So if you don't have this software installed, it's a free application that you can just really install from any web browsing application. Just follow us, and you can always go back and actually do it by yourself. It's not the first class, it's not difficult. So as I said, the right side is where we pick our components, and the first components we're gonna need is a breadboard. Okay, so I'm just gonna click and drag. So this is a breadboard. And it's funny that we call it a breadboard because back then we didn't have these fancy tools to create circuits. They used to have a breadboard, really a board made of wood, and they will just nail things into the board. That's how it's called, breadboard. The same way, this breadboard, I'm gonna go over this breadboard, how it's used. So it's as you say, it's a plastic board made of a bunch of holes. Okay, you can see there's some horizontal holes here. Like when I click on the top one, where it says here it's blue line and it has a minus. Okay, whenever you see green, means these holes are connected. There is a plate in the bottom. Okay, and if you plug something here, that point is connected to any point within this row. Okay, the same thing for the positive, that blue line here, you see. So when I click on any hole, there is a metallic plate in the bottom that connects each hole. So think about that. Okay, in the middle, you have like many columns, as you see here, number 1, 2, and each column has about 5 holes. Okay, so each column, each hole within that column are connected with plates, but they are not connected to the adjacent column. Okay, so notice that when I move my mouse, that green column only represent these 5 holes. Okay, the same thing here, and the same thing goes here. So just give you an example. If I want to connect, for example, this hole which is negative, I can just click and drag. You see, click again, drag, click, drag. Okay, I want you to repeat this. I want you to repeat what I just did. Okay, get a board, either double click or just drag it here, and I want you to connect this point to this point. And then you can adjust. You see, whenever there is this node here or circle, you can actually click on it and drag it to adjust to wherever you want to have it. And you can also change its property. So the property is the color. I can make it, let's say, black. Okay, because normally the blue line here is for ground. Okay, and I'll explain what's ground and what's negative and what's positive. So for now, we are just getting familiar with the tool itself, Tinkercad. Okay. So now I want you to go and grab Resistor. If you can find it, just type Resistor, whatever you're looking for, and you will come up. Okay. So that's what this search bar is for. So just click anywhere really, just leave it there. Just make sure you don't put Resistor like this. This is not correct, because you want basically this is the best way. You want to connect, you want the current to go from here through the resistor and leaves the other terminal. Okay, so that's why we have this channel here which is not connecting anything. So you know, if we connect something to here, it's gonna jump over the resistor and then leaves the other side. Okay, we also need an LED, a light emitting diode. Okay, so see this, I'm sure you've seen them. I'm just gonna put one here and I'll explain you what is an LED. So we have green LEDs, you can make orange, you can make just changing the color, white, blue. All right, let's keep it blue. So the LED, I'll explain you what is LED. Stand for light emitting diode. So think about it as light bulb. When you put some kind of current or voltage, and I will talk about later on what is voltage, what is resistor, what is current. So for now, if you think about currents coming through here, and notice that one leg is kind of crooked and it's longer normally. Okay, that leg is called the anode. That's where current should go through here first. Okay, and it leaves the other terminal, which is called, or the other leg, which is shorter. okay, and it's called the cathode, okay. So I have one here, I have a red one, and I'm just gonna show you that this leg here, this leg is longer, so that is the anode, and this is shorter, that is the cathode, okay. So let's make it long, let's make this leg longer also. So I'm gonna, if I click and I drag, I can just drop it here, and I can just change this, for example, to gray. Really, the color, need to change the color of the you have to highlight the jumper. This is a wire, and I'm just gonna put it gray so it look like it's an extension of the leg, okay. And the other leg, I'm gonna make it shorter, so I'll just put it here. So I'll just make it gray also, okay. So now we have, this is the anode, and if you hover over the this point, it should tells you the anode, okay. And here it is the cathode, okay. So this is actually, normally this is how an LED look like, and I'm just gonna zoom in so you can see it. See that? So this is anode and this is cathode. Okay, so I'll just keep it like that for now. Okay. Okay, what else? Right now we can't see anything because there is no power applied to this circuit, and the circuit is still open, okay. So nothing's gonna happen until we get what we need. We're gonna need some kind of power source. See if we have something here. Okay, well, let's just type battery. There is a 9-volt battery, let's use that. Funny, sometimes it's acting strange, but I've just seen a battery, so here we go. 9-volt battery. So if I click on this one here, and once the component, you have it here on your canvas. This is just like you drawing things. So this is your platform or you design. Actually, you can click on this symbol here where it says rotate, and I can, for example, rotate this one so it looks nicer, like that. Okay. Okay. Now let's apply some voltage, okay. Well, before even we apply, let's do something. I want you to understand some concepts, okay. So what did we say? This is the positive, so we need to get positive is here. We need to click here and get electricity to our anode, okay. So we just do like that. Up. Well, I can edit it, but an easy way, when you click here, do like that, click again on the side if you want to make it look nice, you know. So I'm gonna connect it here, and then later on you can adjust. I can just go like that, I can go like this, and I can move the way how I want it, okay. And let's make this one, let's make it black. I'm sorry, let's make it red. So to change the color, again, the color doesn't mean anything, it's just really for visualization, and it's good. You get used to, like, red is hot, means that's where the current is coming from. So we're just gonna make this red, okay. And let's connect our negative, which is this side. So remember, we cannot connect this leg through here because this is not connected to this, but we can connect it through this. You see all these points here, they are connected to this node here. So we click there, We click here, click there, and we connect it. So when we cross this line here, it doesn't mean that they get connected. So they are like in a different dimension. So don't worry about crossing them. Okay, they don't get crossed. Okay, and let's make this block here. Okay, here we go. Now, just like when you have a light bulb, nothing is going to happen until we simulate. You see this button here which says start simulation. Just like we're going to turn on the switch to see what's going to happen. Oh, look what happened. We burned our LED. A reason why we burned this LED, I'm going to stop simulation. Reason why we burned this LED, because the operating voltage of an LED on average is around 2 volts. And how much voltage we're applying to this LED? 9 volts. It's not gonna work, okay? So we need to kind of reduce that voltage. We're gonna reduce the voltage drop across the LED. And to do that, we need a resistor, okay? So for now, I'm just gonna pick any resistor, and I'll tell you actually why we have to use certain value. And the resistor, if I click on this one, for example, yeah, sometimes the tool is acting. I might have to, okay, so here is the resistor, here is the property of the resistor. So this one is 1 kilo ohm, okay? An ohm is the unit for measuring resistor, and I'll talk about that later on. So for now, let's just get this value here, 350 ohms, not kilo ohms, okay? And I will talk about the color code. You know, the colors within the resistor mean something, and actually that's what determines the value, okay? So look, if, for example, if I click on here, and if I change this to 470, for example, the color changes. You see that? Let's go back to 350. Okay, and I'll explain you how later on, how you can calculate, and based on the color code, you can tell what value, okay? You need to know this also, okay? All right, so now go back here. Now let's see, we're gonna start simulation. You click on start simulation, and I'm gonna slow down a little bit so you can actually follow me and see what's gonna happen. 9 volts, 350, we're still burning the LED. Okay, let's keep increasing. We could put 1000 ohm, which is 1 kilo ohm. Okay, start simulation. I think let me unplug this. This software is acting, shouldn't burn now the LED. I'm gonna delete that, okay, and let's go back. We found a bug in software, but the software is really great, so it's okay if, you know, I deleted this, and I'm gonna go back again. Let's rotate. Let me know if you had the same problem. That would be good to know. So here is positive. We're gonna connect this. Okay, well, I guess I told you this mistake and I didn't pay attention. So the problem was, remember, actually it's good that we made this mistake. So we had resistor connected like that, okay? And that's not good. We have, as I said before, we have to make sure that the resistor is between this channel, so the current will go through here and leaves here, okay? So now let's do it again. We're gonna connect here, but that's how you learn. You learn from mistakes. Remember, Edison had to do like 1,000 tests to really get that light bulb working. So that's a good thing. We do mistakes, and sometimes intentionally, but you learn from it. So I'm gonna connect now this side. I'm just gonna call it red quickly, and I'm gonna connect the cathode of the anode to this side, which is negative. Okay. And for visualization, they just make this one black. Okay. Now,
excuse me.
Yes.
I think I figured out when I made the light turn on.
Oh, that's good.
Burning out.
That's good. Good. Perfect. But that's good. Actually, we made this mistake because then you see, oh, if I do this, that's what happened. So I'm glad actually I made this mistake. So now let's put the value. We can leave 1,000. That's fine. 1,000 ohm. Let's turn star simulation. You see, the light is on. I'm gonna stop. And actually, the exact value for this is 350, and I'm gonna show you how we calculate that. So let's put 350 here. Okay, so it's same thing. Stop. Okay, so were you able to get to this point? I hope you did, but if you
Yes.
Good. If you don't, we're gonna make similar exercise. You get used to it. So really, this is just like you have an actual hardware. Okay, a breadboard, LED. They feel the same. They look the same. And it's safe. You're not gonna burn anything, so it's good, and it's very safe also. Okay, now let's have go further. So instead of using this circuit like this, okay, I want you to introduce a switch. Okay, so click here, type push button. It's strange, my search doesn't work. Or button switch. I think it's called button switch. I don't see it. Here. Oh, push button. Okay. So drag it here, just like the resistor. Okay. Now we want to use the switch to turn on and off this LED. Okay, so this switch is interesting how it functions, so you gotta be careful. So I'm gonna show you how you do it. So let's just delete this one here. So now we're gonna, instead of getting this wire directly to this resistor, we're gonna first, let's say, connect it with the switch. Okay, and I'm gonna explain you how this switch. So I'll just have, let's color this in red. Again, the color doesn't mean anything really, just for visualization, and which one is positive and which one is not negative. Okay, so I'm gonna zoom in on the switch. Okay, so you see this wire here, it goes through that plastic square and it leaves the other side. Okay, so we have terminal 1A, terminal 1B, they are connected. Okay, so if I connect now, if I put a wire here, and I'm gonna zoom out, if I put a wire here and I bring it down here to the resistor, okay, well, it just sometimes doesn't want out. So if I have this configuration here, current is coming from here going through here, and it continue, and it goes here. Really, we didn't do anything with the switch because it's just continuous connection. There is no disruption, okay? And to show you this, I'm gonna click on star simulation. Now I'm gonna zoom out. You see, either we click on the switch or not, it's always on because there is a continuous line going here, okay? So this is not the right way how to use the switch. So I'm gonna move this. Now, instead of connecting this wire, this terminal to this resistor, we're gonna connect either here or this point. These are the same point, okay? So let's just connect here. So we click there and we go, let's just make it fancy. Oh. Like that, okay? And notice any point here, any hole, it will connect with this. So I just choose this one, but you can actually make it here. You can connect it here, it doesn't matter. So let's just change the color to red, okay? Now let's see what's gonna happen. I'm gonna start simulation, okay? So since there is an interruption, so the wire, the current is leaving here, the positive side, and coming here, and then it comes here, and when it gets here, there is no more continuity. So circuit is open. The only way to close this circuit inside the wiring, when you click on this, and I will click on it, it will connect this point with this point, and now the current will be routed from here to here to here. So I'm gonna zoom out just so you can see the LED. Click on, off, on, off, on, off. Are you able to do this?
Yeah.
Good, good. So it's clear how this switch, push button switch works. And it's,
Yeah.
I have one here. It is the same, if you can see it, right here. The same, just like you have the actual hardware actually. Very, can you actually see my camera?
Yeah, we can.
Okay, good, good. Because I'm kind of zoomed in, so I can't see what's going on. Okay, so good. So now the next step, okay, let me explain a little bit what is voltage, what is, so I'm gonna go to my sketchbook. Can you see this blackboard here?
Yes.
You do? Okay, good. Thank you. I need sometimes confirmation. Make sure that you are seeing what I'm seeing. Okay, 1 second. I'm just collecting my board. Okay. And so I just installed this software. Is really great. It's called Sketchbook. You know, if you wanna, you can draw with it. You can do a lot of. You can actually people use it for 3D animations. It's very. There's a lot of YouTube videos on this, how to use it. Very easy to. Still taking a little bit to learn it. So it's great tool. So we're gonna talk about Ohm's law, but let me just make some drawing. All right, so let's pick, let's say red, and okay, let's make a little bit. Okay. I want you to understand this analogy. So I'm gonna just draw a cup. So basically this is my cup of water. Let's fill it up with the blue. I think I lost it. Anyway, so okay, got too many tools. Let's make it, don't want to be too fancy. All right, I'm gonna make a cup here. So this is so imagine there are 2 cups of waters, okay? So this is the first cup, and these 2 cups are connected with this pipe. Okay, let's fill it with some water. So think about there is water here, okay, and the same thing here. Okay, can you see this? Maybe. So now, just to explain what is the voltage, what do you think? So we have the same, imagine this is the same size cup, and in the bottom here there's a hole, and it connects the cup. This is cup 1, and this is cup 2, okay, and this is the same height, okay. This is height 1, height 0, height 0. This means the same height from here to here, okay. So the same thing here. So do you think water is gonna go from, let's say, cup 1 to cup 2, or it's gonna be stagnant like that? Okay. So the water is gonna stay because the cups are at the same height. The water is at the same height. The water is just gonna stay the same way, okay. But now, if we wanna water to move from cup 2 to cup 1, what should we do? We have to raise cup 1. I want you to have fun, so I'm gonna ask question. Really, you don't have to answer the question, and for me, the main thing is to understand and have fun. Don't want to put this question thing. There is in these classes there are no questions. I want you to have fun, and hopefully you learn something, okay? So now, and I'll tell you why I'm doing this analogy so you understand voltage, okay? Let's actually paint this in red so you can see it much better, okay? And I just love drawing also. I'm still learning this tool. Okay, so now I think it's clear. You can even make it like over if you want. Yeah. All right, it look like a cup. So imagine these are the same sizes, but actually they are not, but just the same size. Okay. So for water to flow from cup 2 to cup 1, from here to here, what we need is really to raise cup 1 higher, okay? So I'm gonna erase cup 2 and just make it higher. So let's do that, okay? There's actually a lasso that I can use. There are some functions I haven't practiced yet, so you just select and delete the whole thing. Okay, now let's raise. We said we're gonna raise cup 1 to a higher distance. Oop. Okay. but we're gonna go higher. Yeah, we spend a little bit of time here, but I think it's important. So just to understand this concept here. Okay. Now I'm gonna draw my cup here. Okay. So now the water, you just change the color, and now the water, what's gonna happen? The water is gonna drop, and because we increase the heights of cup 2, and then this water is gonna come from a higher point, and it's going to push because of the gravity, and it's going to push, create pressure, okay, and it's going to move here, and it's going to fill up cup 2. So this height in difference, what we call differential potential, okay, it's this difference in height that actually made water flow from cup 2 to cup 1. The same analogy when we have circuits, and just keep this in mind, we're gonna use the same analogy and compare what is voltage. So the current, when you hear about current, you just think about it as the same as the water current, okay? And when we talk about voltage, it's the same thing as this water pressure made over the water current. And then now let's say we have this pipe, instead of like a wide pipe here, maybe if we have like a thinner pipe, so probably I can reduce the pipe to, for example, by maybe 1 centimeter, and water only leaves here. So resistor is the same thing. The thinner the pipe, more water is gonna have resistor to flow, so the water is gonna go slower, okay? So I want you to think about this analogy, and now let's create circuits, okay? So I'm gonna delete this. Okay, and when we draw circuits, let's get green, red. So the same thing. So we have, let's create our resistor. So I'm gonna create a resistor. Here is our resistor. This is, by the way, this is the symbol of a resistor, and I'm gonna call it R. Okay, now let's create an LED, and this is the symbol of an LED. An LED basically is nothing but a diode. A diode is a electronic component that lets currents only flow in one direction. Okay, and this is the symbol of that. Okay, with 2 arrows means that this component is emitting light. Okay, now let's finish our circuit. To close our circuit, we're gonna need some kind of voltage. Okay, and so we have here positive and negative. Okay, now if we have let's say we used in our exercise we used 9 volts, okay, 9 volt battery. Okay, here it's 9 volts in this terminal, and this side is 0 volts. Okay, negative. Okay, so 0 volts. So the voltage differential between this terminal and this terminal, that's what make the current flow. And currents, the conventional current, can actually go from positive here. We just annotate current with I. Okay, this is called conventional current. Okay, it go from positive and it go round, go through the resistor first, LED, and it comes back to the negative. But actually what's happening is electrons, okay, this potential of difference, just like remember we talked about the height of the water. That's what actually made the current flow from one cup to the other cup. The same thing, it's this difference in potential between potential charges, okay, between this side and that side. That's what it's going to make the current flow. And actually the current, when you talk about current, means electrons, okay, and these particles are inside the copper. They're gonna move the positive charges, gonna attract these negative charges, and these electrons gonna move this way to reach the other end. Okay, so it's the opposite direction of the current. But we don't talk about the electrons, we really just talk about the current. Okay, and all this is to talk about voltage. So we know voltage is this differential potential between two terminals. Actually that's what makes the current flow. Okay, resistor here, it make the current flow faster or slower. It depends how big is that value. Just like that pipe, when we depress it, make it thinner, it's gonna impact how fast the water flow. LED, light emitting diode, is nothing but an semiconductor. You don't have to worry about what is semiconductor. You can Google it, but it's just a component that when applied voltage into it, it will emit lights, and that you need to understand. You know, so that's good. So now we want to understand what is a very important formula or concept that you need to understand. It's called Ohm's law. Okay, very simple, and I'll explain to you. So Ohm's law is one formula that actually it's a relationship between voltage, current, and resistor. V equal to IR. Okay, and R, this is how we got that value. Remember that the 350 that we use for the LED to not burn. R is equal to what? V divided by I. Okay, and so 9 volts, resistor and LED, I'm just gonna call this LED. Resistors and LED, they are connected in series. Okay, and this 9 volt, it's divided between resistor. There is a voltage drop here, I'm gonna call it VR, and there is another voltage drop here, I'm gonna call it VL. Okay, so this 9 volts, everything in life is balanced, there is equilibrium. Okay, so this 9 volts, I'm gonna call it V total. Okay, it's equal to 9 volts. And actually what's happening, we're gonna come back to Ohm's law, but just to tell you how much voltage dropped on the resistor, you have to understand this concept. VT equal to VR plus VL. Is everything clear so far? If you need me to go slower than this, let me know, okay? And the VT is 9 volts, and the voltage, the operating voltage of an LED is approximately 2 volts, okay? So equal 9 volts plus VR, which is unknown, plus 2 volts, okay? So if you do your calculation, V at the resistor, it will be 9 minus 2, it will be 7 volts, okay? Okay, so now to calculate the resistor, we come back to Ohm's law. R equal to V divided by I equal to 7 volts divided by, and another value that you have to know is the LED has an operating current of 20 milliampere, okay? And ampere is the unit of current. So you know, just for now, so basically we take 7 volts divided by 20 milliampere. So 7 divided by 2, and you need to convert milliampere to ampere. So you just multiply this by -3. So when you do your maths, use your calculator, you're supposed to get here 350 ohms. And this funny looking symbol, it's called omega. It's a Greek symbol, and that's what that's the unit of resistor. So this is how we calculated resistor. Are we good? Okay, silence means everyone is good. So I'm gonna go back and continue now. So let me just unplug this board.
Excuse me.
Yes, go ahead.
So I'm using my mom's computer.
Okay.
That's like and my name's Mohammed, but it says Najat here.
Oh, hi Mohammed. Sorry, go ahead.
Okay.
Yeah, go ahead.
So I just wanted to tell you that, just so you know. And that's it, basically.
Okay, thank you. Yeah, and I saw Najat, but yeah, that's good. That's good. Yeah, welcome. And you know, we're going through. I want to make this fun, but really some basic things you have to understand. We will be doing not just this smart car. We will be doing drones. I will be doing actually this session every Saturday, not every other Saturday. Okay.
Oh, okay.
Every Saturday. And if you have, I'm gonna record this and I'm gonna put it under my YouTube channel. You can review it, and things gonna be like adding up. So just be. It's not difficult. Nothing is difficult. But just step by step. You know, you cannot fill up a cup quickly. You know, it takes like drops of water. So step by step until we get to the point where I'm going to be talking about other things to build that car, okay? But this is the Ohm's law is really the bread and butter. You have to understand it. And I guess since you didn't have any question, means everything is good.
So it's every Saturday at 2, right?
Every Saturday at 2, exactly.
Okay, thank you.
You're welcome. Thank you. So now let's do some fun now, okay? So we did. Let me see if my mouse. Okay. Okay, now we're gonna move the switch. Okay, so the reason why I put this switch in this exercise, okay, is really to introduce another component which is very important, and actually that is the main component that we're gonna be using. It's called Arduino. Okay, it's a microcontroller, just like any hardware, like your smartphone, your laptop have some kind of microprocessor. Okay, the same thing. Arduino is that microprocessor, that's the brain. Okay, so now when you click on the switch, what happened? Actually, there is a signal from your brain that's get generated, sent to your spinal cord, to your muscle, to your finger to press. Okay, so there is some kind of function. I'm not gonna call it program, but it's a function that actually happened inside your brain and send some specific signal to your finger, okay, to press this button. So now we want to replace the function of your brain with a microcontroller, with a program, okay? And let's do that. Okay, that's what we're gonna do now. Now we don't need this battery because we're gonna use an Arduino to control, and the Arduino actually is gonna supply voltage also to the LED. So we don't need that, okay? We don't need the switch. You just click and delete. Click on the component, and on your laptop, you just click on delete. See that? Okay. Now let's look for Arduino. You scroll down until you see this red, blue, big box. It says Arduino Uno R3. You just drag it here, okay? And you can rotate it. So basically, I'm just gonna rotate it. And I will have one class really just about Arduino. So I'm just gonna tell you the keys that you can just delete this. Some of the pins that you need to know for now, for today. So let me zoom out a little bit so you can see. Okay. Now quickly I'm gonna talk about Arduino, okay, without getting too much into the Arduino itself. So the Arduino, it's a development board that has a microcontroller. You see this one here, it is that black long component here, without coming up with names. And this is your microcontroller. This is actually the brain of this board completely. And there's some wiring inside this plastic that actually extend those pins to these outside terminals here, okay, these headers here, okay. So the microcontroller is this one here. We have some pins they go from 0 to 13. These are digital pins. This is actually where we're gonna be using to program Arduino, okay. Some of them have this squiggle, you see that? So for example, pin number 3, pin number 6, pin number 9, 10, 11, they have squiggle here, you see that? This squiggly symbol means these are PWM pins. These are analog pins, and I will talk to you about what does it mean and how we can use them, okay. There is some, when you see GND, that's ground, okay. And then we have some analog input pins, A0 to A5, and I will talk about how we can use analog and what is digital, what is analog in other classes. And you have here, we have this area here is for voltage, for power. We have ground, VN, 5 volts, 3.3 volts, reset. But don't worry about anything right now on this. All you have to know is where is my power, okay? And we can use this, or we can use supply actually when you connect your USB of your laptop to this Arduino. And that's how you're gonna normally in real life, that's how you're gonna program this microcontroller using your laptop, okay. So when you connect USB to this port here, you're supplying voltage, so we don't have to worry about voltage for now, okay, for this exercise. This is your ground, okay. So now let's, for example, do this. I'm gonna collect pin pin number 13 to here. Okay, good. All right, so we're connecting pin number 13 to our resistor, and then we're gonna connect.
You need to share your screen.
I got disconnected. Thank you. So we're connecting pin number 13 to this resistor, okay? And make sure also you connect your ground to the other side, to the other terminal of the LED, okay? Okay, now under code, you see that? If you click on it, there is a built-in, and I'll tell you the reason why we connected the pin number 13. And then later on, we're gonna actually choose different pin, okay? So if you click under code here, okay? These are called block codes, okay? Made of the same, and I'll show you actually when you, the actual code that you put in Arduino. If you click under blocks and you go block and text, you see here, this is the actual code. This is what we're going to be learning, okay? Okay, so when you see set built-in LED to high, look what it says under the text. Pin mode, pin 13. And we want pin 13 to be output, okay? So let me just go back to blocks, okay? So let me kill this one here to explain you something, okay? So pin 13 here, there is an LED here. We see where it says L. This is actually built-in LED. And this built-in LED is connected to pin 13, okay? So we connected this LED also to our LED here on the board. So normally when this code, when we do simulation, and the simulation now I can explain you briefly how this is gonna happen. Under the simulation, set built-in LED to high means the voltage coming from the USB from the laptop is 5 volts. Means we're gonna send 5 volts through our pin 13, okay? So 5 volts, it's like you put in a battery there, okay? But not 9 volts, it's 5 volts. And then we're gonna wait 1 second, okay? Means turn it on and do nothing for 1 second. That's what wait, okay? And then we're gonna then the next code, it's set built-in LED to low, means turn it off. That's what low means. Because in the world of computer, really all it knows is just voltages inside, either high or low. And some people talk about binary numbers, okay? Either 0 or 1, 0 or 1. So this is actually how programming, and it's called machine language, okay? So it's either 0, 1, 0, 1, and we call this binary, but don't worry about that for now, okay? And then we wait, once we turn it off, we wait another 1 second. And this code keep going on and on and on, looping. It's basically that's what's happening. So let's do the simulation. Okay, I'm gonna start simulation, and I'm just gonna so you can see here is light bulb flashing. You see that? And the light bulb is flashing here too. See that? Okay.